All right, so for today, and this may carry on into tomorrow, but for today, what we're going to do is work on properties of exponents. It's an eighth grade standard. We'll go ahead and work on it. So the first thing I want to discuss is the power of zero. So for the power of zero, the answer is always going to be one, not zero, but one. So here, and let me go over something before I even um, touch this stuff at all. So let me show you what a base and an exponent actually are. So let's just look at just basic recall. If you see something like 5 squared or 5 to the second power, 5 is called your base and 2 is called your exponent or your power, okay? All right, and that exponent tells you how many times to multiply the 5. So 5 to the second power, 5 squared, is basically written as 5 times 5 or just 25. If you see something that looks like this, let me erase that. X is your base and 5 is your exponent. Okay. If you see something that's written like this, let's see. Here you have two bases. X is a base and Y is also a base. And you have two exponents. You have an exponent of 2 and an exponent of 3. Okay. The exponents are the ones I circled. Also here, if you ever see anything that looks like this, it does have an exponent. It's an understood one. Or if you see something that looks like this, it does have an exponent. It's an understood one, okay? Okay. All right. Now, since we know that, let's go ahead and look at anything to the zero power. Your base is x, but it's raised to a power of 0 or exponent of 0. Well, anything that is raised to a 0 power that has 0 as an exponent is always equivalent to 1. So that whole thing equals 1. Well, the base of 92 is raised to the 0 power. It has a 0 as an exponent. Again, if it has 0 as an exponent, we say it's a power of 0. The answer is 1. And this whole thing is inside of parentheses. So basically, all of this is raised to the 0 power because all of that is in parentheses. So all of that just equals to 1. Again, anything that has an exponent of 0 is always going to equal to 1. All right, but look at let's take a look at D. D is a little different. So the only thing that's raised to the exponent of 0 is the y. Your exponent only applies to what is directly to the left of it, which is the y, unless it's inside of parentheses. Now, had all of this been in parentheses, then that 0 would have applied to the whole thing. Okay, but it's not in parentheses, so the 0 doesn't apply to the whole thing. The 0 only applies to the y. So in this particular case, only the y will change to a 1. So you got to keep the 12. Okay, keep 12, but the y changes to a 1. Well, these two are mashed together. So when they're mashed together in math, we say it's multiplication. So basically we can say 12 times 1 is 12. So my answer here is 12. Okay. The only thing here that's raised to the 0 power on E is what is directly to the left. Directly to the left is the base y. So on the y is going to change to a 1. So you're going to have 5, keep it, x squared, keep it, times 1, times, because it's all mashed together, so I can say times, and keep z to the third power. Well, take your two numbers and multiply. 5 times 1 is 5. So the question becomes, well, what do I do with this x squared? I'm going to have to do it in green. what do I do with this and this? Well, you can't do anything with them. You can only multiply the 5 and the 1 because they're regular numbers. So you just write down x squared and z to the third power next to it. If you're confused about something on this part, stop the video and raise your hand. I'll come to your desk. Again, the exponent, I'm going to go back to D. The exponent of 0 only applies to the y because it's not inside of parentheses. So only the y changes to a 1. And I just bring down the 12 and just say 12 times 1 is 12. But on C, this whole thing is inside of parentheses. So all of it is to the 0 power. So all of it changes to 1. Okay? Okay, let's take a look at 2. The second property we're going to learn about is the negative power rule. All right, so if you have a negative power, which means you have a negative exponent. All right, if you have a negative exponent, what you're going to do is you're going to make the exponent positive by doing something, okay? You're going to make the exponent positive by flipping it. And when I say it, I'm not referring to the exponent, although it sounds like that. Okay, the it I'm talking about is the number or the variable that you see. So on A, I see the variable x. That's what I'm going to flip. Okay, so make the exponent, reading this again, make the exponent positive, okay, by flipping the number or the variable, or what we say, or using what we call the reciprocal, okay? Reciprocal is just when you flip something. So you all saw keep, change, flip when we were dividing fractions yesterday. Basically, when you flip that fraction, you were using a reciprocal. So let's talk about reciprocals or flipping just real quick before I even touch bases on the problems. So if I wanted the reciprocal, or I wanted to flip 2, well, to flip it, I just know that 2 is over a understood 1. You don't see the 1, but it's actually there. So if I flip it, it's 1 over 2. Okay? So that's the reciprocal of the flip of 2. The reciprocal of 5 is simply 1 over 5. The reciprocal of x is simply 1 over x. Just flip it. Okay? So that's what I mean when I say reciprocal. Okay, so here I have a base of x. So because my exponent is negative, I'm going to make it positive by flipping the number of the variables. I'm going to flip the x. I got the variable x. So if I flip x, it becomes 1 over x. But then you make your negative 5, which is your exponent, a positive 5. Okay? It's as simple as that. So you just take your base and flip it. And you make your exponent positive when you do. So if I flip x, it becomes 1 over x. And make negative 5 a positive 5. That 5 stays with the x, okay? All right, if you take a look at B, B says 2 to the negative third power. Well, again, I got a negative exponent. So I'm going to take my base of 2 and flip it. So if I flip 2, I automatically see flipping 2 gives me 1 over 2. But then I have to take my negative exponent and make it positive. Okay? So basically, I just took flip 2, made it 1 over 2, and negative 3 became a positive 3, but that 3 stays with the 2. So I can leave it as this, like this. I can leave it like this, which is what we call an exponential expression, because I left it with the exponent. Okay. Or I can write it as a numerical expression. To write it as a numerical expression, you're going to write 1 over, and 2 to the third power is 2 times 2 times 2. Basically, I get 1 over 8. That's my answer as a numerical answer, okay? That means 3 2s. 2 times 2 is 4. 4 times 2 is 8. All right, you can also flip the other way. So if you see 1 over x to the negative third power, it has a negative exponent. But if I flip 1 over x, it becomes x over 1, which is just x. But instead of keeping the negative 3, I put a positive 3 on it, okay? Whenever you flip it, you change your exponent to positive. So I just flip these two. All I did when you flip, you just switch these out. The x goes to the top and the 1 goes to the bottom. But negative 3 becomes positive 3. But x to the third power over 1 is just x to the third power. Just like 5 over 1 is just 5. So x to the third power over 1 is just x to the third power. Okay, let's take a look at D. If you look at D, the only base that has a negative exponent is A. It's the only base. Okay, so only A is going to flip. Okay, because it's the only one that has a negative exponent. So the 5 doesn't flip and the B doesn't flip. So when I say flip, I mean flip it to the bottom. Okay, but there is no bottom, so you create your own bottom by drawing a bar. And you're going to keep the 5 and the B to the fourth on the top. But this is going to flip to the bottom. So, and then once you flip it, negative 2 becomes a positive. The exponent becomes positive once you flip it, okay? And that's all you do. You can't have a negative exponent. So if you see a negative exponent, get rid of it. And the exponents are the little numbers. So if you take a look at E, negative 2 is not an exponent. It's actually what we call a coefficient. It's a number in front of a letter. Negative 2 is in front of the letter A and in front of the letter B. So it's called a coefficient, not an exponent. Negative 3 is an exponent because it's the little number, okay? Now somebody is going to ask me, if you look at B, 2 is not an exponent, it's not a coefficient because it's not in front of any letters. There are no letters that follow it. Okay, so we just look at this as a regular base. But this we look at as a coefficient because it's in front of some letters. Okay, guys? All right, so we don't worry about those. We're going to look for these negative bases, these negative exponents. There's a negative exponent, and it applies only to the B. And I found another negative exponent. Here's a negative exponent, and it applies only to the C. Remember, the exponent only applies to, to what is directly to the left of it, unless it's inside of parentheses, and it applies to all of it. But there's no parentheses on E. So I just take a look, and I'm going to flip the B and the C because those are the only ones that have a negative exponent. So I'm going to draw my bar back. I already have a bar. Just draw it back. Keep the negative 2 where it is. Keep the A to the fourth where it is because 4 is not negative, okay? All right, keep the 5 where it is, which is on the bottom. Keep the D where it is because 7 is not negative. So keep it where it is, which is on the bottom. Now what you're going to do is you're going to take the things that have the negative exponent and you're going to flip them. So B has a negative exponent. I'm going to flip it to the bottom. And once you flip it, the exponent becomes a positive. You make it positive. C has a negative exponent. So I'm going to flip it. Well, if you flip it, if it's on the bottom, it will flip to the top. If it's on the top, it flips to the bottom. If it's on the bottom, it flips to the top. Only if they have negative exponents, okay? If you don't see a bottom, create one and flip it. So that's why I flipped this A down here on that problem, okay? All right, but C, go back over here. C was raised to a negative exponent. It was underneath the bar, or on the bottom of the bar, so I flipped it to the top of the bar. But negative 4 needs to become a positive 4. Now I have no more negative exponents. Again, I don't want anybody to think, oh, there's a negative exponent. That's not a negative exponent. It's a negative coefficient. Okay? Exponents are the little numbers at the top. Okay, let's take a look at 3. 3 says multiplying powers with like bases, and the key word here is like. Okay, gotta be like before you can use this rule. So your rule, once you see powers that have like bases, in other words, the bases are the same, you're gonna keep only one base. Okay? You're gonna keep one base and add the exponents. So just remember this. Multiplication of powers with like bases, you add the exponents. Okay? But you keep one base. So for instance, I have a to the fourth times a to the second. Well, I'm going to keep one base. So I don't want to write both of these bases because I have a base a here and I have a base a there. I only want to write one base a. So I just write one base and do what with the exponents? Add. So if you add 4 plus 2, you get a to the 6. You want, hold on. All right, now let's take a look at B. Hold on, guys. There's something going on in my neighborhood. I keep hearing dogs bark. It's bothering me. Hold on.
Your call has been forwarded to an automated voice messaging system.
Kristen? 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 I'm just checking on you. I was just checking on you. Okay. Sorry about that, guys. Let's take a look at B. So for B, I have a base x here, I have a base x here, and I have a base x here. Okay? So I'm multiplying all of these bases, and they are the same. They're like. So I only want to write one of them. So just write one base x. Just write one. Okay? And then do what with the exponents? Add. Now remember up here, I told you that if you just see an x, it has an understood exponent. I mean, an x with no exponent or a number with no exponent, it has an understood exponent of 1. So you're going to have to make use of that concept down here. So right here, this x does not have an exponent, so I'm going to put a 1. So now I'm going to add 1 plus 5 plus 2, and I get 8. So this becomes x to the 8th power. All right, here I have a base 2, got another base 2, got a third base 2, but I only want to write one base 2, so just write a 2. And what are we going to do with these exponents? We're going to add, because you're multiplying with like bases. All these bases are 2s. Okay, so this is a problem. This one has an understood exponent of 1. So I'm going to add that, put that 1 there, and I'm going to add my bases. My exponent, 2 plus 1 plus 2 gives me 5. So now I have a new exponent of 5. That's 2 to the 5th power. Now, if you want to write it out, that's 2 times 2 times 2 times 2 times 2, which is just 32. Because 2 times 2 is 4, and that's another 4. So 4 times 4 is 16, and 16 times that last 4 will give you 32. Okay? And let me rewrite this because somebody's not going to understand it. Okay. So these two make 4. These two multiplied together make 4, and I'm going to bring down that last 2. So I end up with 16 times 2, which is 32. Okay? So you can leave it as 2 to the 5th power. That's exponential. That's what we call exponential form. Or you can write 32, which is what we call numerical form. Okay? Either one is fine with me. All right, let's take a look at D. And if you look at D, you have one base that's -3 and another base that it is -3. So instead of having two -3s, I'm going to write one -3. And because my base is negative, put it in parentheses. Anytime your base is negative, I'll put it in parentheses, okay? All right, there's an exponent of 1, so I'm going to add 1 plus 2 is 3, so I get a 3 there. Now, what you cannot do is go through and say 1 plus 2, and then say plus 2, plus 7, plus 8, plus an understood 1. You can't add all the exponents you see together. And the reason you can't do that is because the -3 only matches another -3. So you can only put one. I want to do that. Hold on. You can only put 1 with 2 because they're the only bases that have -3. Over here, I can put 2 with 7 because both of them are A. So I'm going to write 1A, and 2 plus 7 is 9. And then I can write 1B, and I would just say 8 plus an understood 1, which is 9. So B to the 9th power. And you don't have to put these little dots in between. I just do it right now. But -3 to the 3rd power is -3 times -3 times -3. That's 9 times -3, which is -27. So this makes -27. So I can write -27, 8 to the 9th, B to the 9th. Do that for me. Whenever your base starts acting as a coefficient, okay, so whenever you get an answer and that number with an exponent is left in front of some variables, change this to a regular number like -27. But only do it if it's left in front of some variables. Say, for instance, on something like this, you could have left 2 to the 5th like that instead of changing it to 32. But when you get to something like this right here, because there are some variables that sit there behind it, change that to a regular number, okay? All right, I have two base x's. So I'm going to write 1x, and I'm going to add the exponents. I'm going to take -3 and -5 and add it to 3. Now, I know I said add, but you got to follow integer rules, guys. These two go in opposite directions. That goes to the left, and this one goes to the right. And you're going to apply SAD. Same direction, add, different direction, subtract. Well, these are different, so I'm going to subtract, and I get -2. Okay, but keep in mind, you cannot have a negative exponent. Okay, you can't leave a negative exponent. So we're going to go back to this rule. If you have a negative exponent, you're going to make the exponent positive by flipping the number or the variable, which is also what we call using the reciprocal. So I'm going to have to flip this base x. So if I flip x, it becomes 1 over x. But when you flip it, you make your exponent positive. So basically, it's 1 over x to the 2nd power. You flip it because it has a negative exponent, okay? All right, let's take a look at this one. People would think, oh, the base is -3. But here the base looks like +3. But those aren't like, guys. A -3 is not like a +3. This is a +3. They're not like. So if you look at it as a -3 and a +3, you can't put the exponents together. You can't add the exponents. So what you do is you just bring it down. Okay, basically you ignore it by bringing it down. So now since you're bringing it down, you can look at it as a 3, and a 3 instead of a -3 and a 3. You can look at this as a 3 and another 3. If I can get my highlighter to work. Okay, I can look at them as 2 3s if I bring that negative down. Now on something like D, both of these bases, if you look at D, both of these bases were -3, -3. So you can write -3 and add the exponents to the third power. But see, both of these don't look like -3. So if they both don't look like a negative, bring the negative down and look at this as a 3 and another 3. So if I bring the negative down and I look at it as a 3 and another 3, I'm going to write 1, 3 and add the exponents. That's an understood one. 1 plus 2 is 3. Okay? And then instead of 2 A's, I can write 1 A and 2 plus -7. But this goes to the right and this goes to the left. They're in different directions. So I'm going to subtract. I get -5. Okay? So what I'm going to do is I'm going to multiply this out. I'm going to keep bringing this down because remember, both of the 3's weren't negative. So both of the 3's or the numbers aren't negative. You keep bringing that negative down. And this is 3 times 3 times 3 times a to the -5th. Okay? So 3 times 3 is 9, and 9 times 3 is 27. But I keep bringing that negative down because both of these bases weren't -3 times a to the -5th. But I still have a problem though. I have a problem because this a has a negative exponent, so I need to flip it. Well, you're saying flip it? Yeah, flip it. Well, flip it where? Well, you create a bottom and you keep the -27 on the top. And you flip this to the bottom and make your exponent positive, okay? Remember, if it has a negative exponent, you flip that base. I'm going to flip A, okay? Flip it to the bottom. Now, if you just saw a to the -5th, you would have to put 1 over a to the 5th when you flip it. But because you already have a 27, don't put 1 over a to the -5th. Put -27 over a to the 5th, okay? All right, let's take a look at this one. Here I see a base x. Here I see another base x. Here I see another base x. And I know when it's all mashed together with parentheses, it also means multiply. So I'm still multiplying with 3 base x's. So I'm only going to write 1 x. But what can I do with these exponents for the x's? So I'm going to take 2 and add it to 8. And then add it to -12. So that's going to be 10 plus -12. And if you use SAS, the 10 goes right and the 12 goes left. So that puts me at a -2. Okay, now I got a base y, I got another base y, and I got a third base y. So I got 3 base y's and I'm multiplying. So I only write 1 y. So what are you going to do to those exponents? You got a 5, you got an exponent of 3 on that y, and you got an exponent of an understood 1 on that y. So if you add, you get 9. So you put your 9. Okay. Now, I know some of you are saying, well, Miss Blue, you skipped something. What do I do with the 4, the 3, and the 2? They're not exponents. So what do I do with them if they're not exponents? Well, you do what it means when you see them all mashed together. What does all mashed together means? All mashed together means multiply. So what do you do with these big numbers? You multiply 4 times 3 times 2. That's what you do with the big numbers. We call these coefficients. Okay, because they're in front of letters. They're in front of the letters of variables x and y. So we get 12 times 2, which is 24. And that sits back right there in front of it. Oh, but I'm not finished. Okay. I'm wondering if anybody knows why I'm not finished. I'm not finished because I have a negative exponent. Okay. So I have a negative exponent. So this, I'm going to flip base x. Because the base with the negative exponent. So I just create a bar, and I'm going to keep the 24 on the top and keep the y to the ninth on the top, but I'm going to flip that x to the bottom. And when I flip it, the exponent becomes positive. And that's what you end up with. Okay. All right, I'm going to do h, and I'm going to say dividing powers and a power of a power for tomorrow, okay? Say those for tomorrow. But let's look at h. Okay, so I see a base x here. I see a base x here. So I'm going to write 1x. And I'm going to take these exponents above the x's and add them. -3 plus -7. When I say add, I mean put a plus sign in between. Both of them go to the left. So I know to add, act for real, and I get -10. Okay, now this is base y, and this is a base y. All right, so I take the exponent of 2 and add it to the exponent of -8. Just because I say add it to doesn't mean I add the actual numbers. That just means I put a plus sign in between them. And I follow SADs. Like I followed SADs here, and they both went in the same direction, so I added. Here, this goes to the right, that goes to the left. They go in different directions, so I subtract. I get -6, y to the -6. Okay, now what are you going to do with these numbers? This and that. The other big numbers are coefficients. You multiply them. -5 times 4 gives me -20. And it sits right there in the front. It acts as a coefficient. I'm not finished though, because the problem here is that the x has a negative exponent and the y also has a negative exponent. So I'm going to flip both x and y. And somebody said, well, why don't you flip 20 or -20? Well, -20 isn't an exponent. It's acting as a coefficient. It's acting as a big number. You can only flip the bases if they have negative exponents. So I'm going to draw a bar because I don't see a bar on this already. I don't see a bar in here. I'm going to keep the -20 where it is, and I'm going to flip x to the bottom and make 10 positive. Flip y to the bottom and make 6 positive. And that's all you do. All right, guys, that's it for today's lesson. I'll pick up on the rest of these notes on tomorrow, okay? Thank you.